In this question, it says Sarah can paddle 3 kilometers an hour in still water. And so I've shown, like, here's Sarah in her little canoe, and she can paddle 3 kilometers in still water, and she can do that either down or up. And she travels 5 kilometers upstream against the current and 5 kilometers downstream against with the current. So the distance that she's going is 5 kilometers. Her rate is 3 kilometers an hour. But since the current is going to push her, we're going to have faster speed going one way versus the other. And it says the trip took her 3.75 hours. Determine the speed of the current x. Okay, so we first of all need to establish that the distance is equal to velocity times time. So see this triangle here? This is what determines the relationship. I need to come up with an equation for the time. Oops. I need to come up with an equation for time. Okay, so because it says here the trip took her 3.75 hours. So my equation is going to look like this. The 3.75 hours is going to be equal to the time upstream plus time downstream. Now to get the time, we need to have an expression for time. So I need to rearrange the distance equals velocity times time formula. And to get time, we go time is equal to the distance divided by velocity. So I'm going to then rearrange this expression. So I'm going to actually, first of all, convert this 3.75 hours into 15 over 4 hours. Okay, that's going to be equivalent to 3.75. I'm going to do this as a rational expression, so I want fractions. I want time upstream. So the distance upstream is 5 kilometers. Now, if I'm going upstream, I'm going against the current. So I'm going to have my paddling speed, but it's going to be working against the current. So it's going to be, my velocity is going to be 3 minus x. Then I do the same thing for my time downstream. My distance downstream is 5 kilometers. My paddling speed is 3 kilometers, but now I'm going with the current. So it's going to be, I'm going to add the current to my velocity, and that gives me my distance divided by velocity expression for up and down. So at this point, I now have my equation. I just need to solve this rational equation. I want to get rid of my fractions. So I'm going to times by 4. Oops, before I do that, I should state my restrictions. X cannot equal 3 or negative 3. So my current can't be be equal to the current, or sorry, my paddling velocity. Otherwise, I'll be going nowhere, and it would take me forever to get anywhere. Okay, so just going to make sure I highlight a couple things here so we see which things are related. So this equation here came from that 3.75 hours. So I'm going to now get rid of the denominators by multiplying through by 4, 3 minus x, 3 plus x. Okay, multiplying through by that, I get 15. 3 minus x times 3 plus x. Maybe I'll do that. Make sure I write that out first. I'll do a couple extra steps here. I'm going to times by 5. The 3 minus x cancels. I still have a times 4. A times 3 plus x. Okay, plus 5. The 4 doesn't cancel, so I have a times 4. This time the 3 plus x cancels, so I'm just left with the 3 minus x. Okay, I don't need a common denominator because I'm just multiplying both sides of the equation. So instead of balancing the fraction like I did in some problems, I'm now balancing the equation. So expanding this out, I'm going to expand the brackets first. These are conjugate pairs, so I get 9 minus x squared. Here I'm going to get 20. Actually, I could just multiply that out. 5 times 4 times 3. 5 times 4 times 3 is going to give us 60. 5 times 4 times x is going to give us 20x plus 5 times 4 times 3 is going to give us 60 over here. And then 5 times 4 times negative x is going to give us minus 20x. So as this equation is resolving itself, we can see that they have some zero pairs. So those cancel out. And on the right-hand side, sorry, left-hand side, I'm going to go 15 times 9. That's going to be 135 minus 15x squared. That's going to equal 120 on the right-hand side. I'm going to go subtract 120 from both sides, add 15x squared from both sides, solve for x. So the current must be going positive or negative 1 meters per second or kilometers per hour. Now, it doesn't really make sense that the current is going backwards, although maybe technically it could. And if that was the case, this would still actually work. I'm just going to assume that current is going to go down. It's going to be positive. So the current is 1 kilometer per hour.